Hi, this is Alex from devstories.eu. Prompt Flow, the Complete Guide, Episode 8 of 14. You deploy a new language model app, but every time a user sends a message, it takes precious seconds just to establish the database connection and load the client credentials. When your application needs to maintain a persistent connection or remember conversation history, a standalone script fails because it starts completely from scratch on every run. The answer to this problem is FlexFlows, class-based development. When you build applications that scale, state management becomes a primary concern. If your flow relies on an external resource, like an Azure OpenAI client, initializing that client requires reading secrets, verifying endpoints, and allocating memory. If you put that logic inside a basic execution sequence, you pay that heavy startup cost every single time a request comes in. Using a Python class as the entry point for your FlexFlow allows you to fundamentally split your initialization logic away from your execution logic. A class-based flow relies on two standard Python methods to manage this lifecycle. The first is the constructor, or the init method. This is your setup phase. Prompt flow runs this method exactly once when the flow is first loaded into memory. This is where you do all the heavy lifting. The second method is the call method. This is your execution phase, and it runs every time the flow is triggered by a user request. Picture a chat flow class. You define your init method to accept an Azure OpenAI connection object and a system prompt string. Inside the init method, you create your Azure OpenAI client and store it as a property on the class instance itself. The client is now ready and waiting. Next, you define your call method. This method accepts a new user question and a list of past messages representing the chat history. Because the client is already fully initialized, the call method immediately formats the prompt, sends the chat history to the language model, and returns the response. The execution is fast because the expensive client setup was completely bypassed. To make this work, prompt flow needs to know how to instantiate your class. You configure this by creating a YAML file for your flow. The entry point in this configuration file uses a specific format, naming the Python module followed by a colon and the name of your class. This is the part that matters. Your YAML configuration does not just point to the class, it defines the parameters required by your init method. If your class constructor requires an Azure connection and a model name, you declare those inputs in the YAML file under a dedicated init section. When the prompt flow engine starts, it reads the YAML, injects those configured parameters into your class constructor, and then keeps that instantiated object alive in memory to handle incoming calls. Testing a class-based flow locally is incredibly straightforward because it relies on standard Python behavior. You do not need a complex test harness. You just write a standard Python script, import your class, create an instance by passing in mock connections or local credentials to the constructor, and then invoke the object directly by passing a test message to it. You can debug the setup logic and the execution logic independently. The core takeaway is that class-based flows give you the architectural structure to separate the heavy lifting of initialization from the repetitive work of execution, keeping your state persistent and your responses fast. If you find these episodes helpful and want to support the show, you can search for devstories.eu on Patreon. That is all for this one. Thanks for listening and keep building.